Hi everyone, welcome back to the channel. In this video, I'll explain why 180 degrees of CT scan is not enough when using fan beam geometry. We'll talk about why we need 180 plus the fan angle, what the fan angle really means, how Parker weighting works, and finally, how short scans compare with full 360-degree scans. And here's the hook. If you've ever worked with cone beam CT in radiation therapy, you'll notice significant reconstruction artifacts if you only acquire 180 degrees. That's exactly due to incomplete data acquisition. And today we'll see why. In parallel beam geometry, things are simple. The X-rays travel as straight parallel lines. For every projection angle theta, there's a complementary projection at theta plus 180. That symmetry means that scanning just 180 degrees is sufficient for reconstruction. But in reality, neither diagnostic CT nor cone beam CT in radiation therapy use parallel geometry. Instead, we work with fan beam geometry, and that changes the story. Now, let's look at fan beam geometry. Here, the X-rays diverge from a single point source, forming a fan shape. The fan angle is simply the spread of that beam from both ends of the detector array. Because of this divergence, 180 degrees of scan is no longer enough. If we only sample 180 degrees, some points, especially near the periphery of the object, won't be sampled over a full 180 degrees of projection angles. And that full angular coverage is essential for exact reconstruction. In fan beam CT, we need 180 degrees plus the fan angle to guarantee complete coverage. The real requirement is that every point in the object must be sampled over at least 180 degrees of rays. If you stop at exactly 180, the outer points won't get full angular coverage. By adding the fan angle, you ensure that every single point, even those at the edges of the field of view, is fully sampled. For example, if the fan angle is 40 degrees, then we need 180 plus 40, which is 220 degrees of scan. This brings up another issue, redundancy. In a short scan that covers 180 plus the fan angle, some rays overlap. That means the same line through the patient is measured more than once. If we simply reconstruct using all of them equally, artifacts will appear. That's why proper weighting is critical. To handle redundancy, we use Parker weighting. At the beginning of the scan, rays are smoothly weighted from 0 up to 1. In the central region, the projections are fully weighted, and toward the end of the scan, the weights decrease smoothly from 1 back to 0. This continuous transition avoids abrupt jumps and ensures artifact-free reconstructions. Now, let's compare short scans with full scans. In a short scan, 180 degrees plus the fan angle, we need Parker weighting to balance the redundant rays. In a full 360-degree scan, every ray has a true complementary ray, so the weighting is much simpler. All projections are just uniformly weighted by 1/2. To summarize, 180 degrees is sufficient only for parallel beam geometry. In fan beam CT, we require 180 degrees plus the fan angle so that every point in the object has complete angular coverage. Short scans use Parker weighting to manage redundant rays, while full 360-degree scans use simple half weighting. Now, one final note. This discussion applies to analytical reconstruction methods, such as filter back projection. In modern iterative reconstruction, you often hear about sparse acquisitions that reduce those. Those methods leverage additional information, such as anatomical priors, cost functions, or similarities across scans. That's very different from conventional analytical reconstruction, which is what we have been discussing here today. If you found this explanation helpful, please give the video a thumbs up and subscribe for more content on medical physics and imaging. Leave a comment below if you'd like me to dive deeper into iterative reconstruction or other advanced CT techniques. And don't forget to share this with colleagues who might benefit from understanding why 180 degrees alone just isn't enough in fan beam CT. Thank you for watching. See you next time. Bye.